Hello friends, welcome to the class of High Voltage Engineering. So in previous lecture, we have discussed the series resistance micrometer method, resistance potential divider method, generating voltmeter, series impedance emitter, capacitive potential divider, capacitance voltage transformer, electrostatic voltmeters, and series capacitance peak voltmeters. So these methods are used for the measurement of DC voltage and AC voltages, but it is at power frequency. We cannot measure the impulse voltage magnitudes or other rapidly changing voltages or the high frequency high voltage AC produced by the Tesla transformer with the help of these methods. But if you can observe the tables thoroughly, there is one method which can be used to measure any type of the voltage level, and that is the sphere gap. So in today's lecture, I am going to discuss about the two methods through which we can measure the high voltage DC, high voltage AC at power frequency, high frequency high voltage AC impulse voltages and other rapidly changing voltages with the help of sphere gap assembly, and as well as I am also going to discuss the series capacitance peak voltmeters or the series peak voltmeters to measure the peak magnitude of impulse voltages or the switching over voltages in high voltage laboratories during the testing. So the methods that we have discussed for the case of AC voltages at power frequency, like series impedance emitter or series impedance voltmeter method, resistance potential divider, capacitance potential divider, then the capacitance voltage transformer, series capacitance voltmeters, all these methods normally measures the RMS value of the voltages. But if we are considering the case of the breakdown, the breakdown is always initiated at the maximum value of the voltage or the peak magnitude of the voltage. So the testing engineer has to define in his or her report the peak magnitudes at which the flashover situation may arise while the testing has been conducted on the insulations or the high voltage equipments. So to measure these peak magnitudes, normally the sphere gaps are more appropriate as compared to the other techniques. But sphere gaps alone cannot give us the measurement, so they always associated with the measuring equipments like the resistance potential dividers. So today I am going to discuss about the two techniques, the sphere gap assembly and the capacitance peak voltmeters. So let us begin with the sphere gap. So here I have shown you the photograph where it represents the vertical arrangement of the two spheres. As you can see that how they looks like in high voltage laboratories. For the larger magnitude of voltages, normally the vertical sphere gap assemblies are more preferable, and if the voltage level is too low, then one can use the horizontal sphere gap assembly as well. So here this is how the arrangement is provided with some dimensions. So in diagram you can see the number one. Let me spot that. Let me spot the number one. So here you can see the number one. The number one represents the insulating support. So this is the insulating support. As you can see that the insulating support is provided. Okay, so ultimately it gives the electrical isolation between the high voltage electrode and the ground, as well as it provides the electrical isolation between this metallic portion and the high voltage electrode when the high voltage is being applied. Okay, so and also of course it provides the mechanical kind of support. So this is the insulating support which provides the mechanical support to this sphere gap assembly. Second number, that is the sphere shank. Okay, here this is the shank. Okay, it may be the insulating support, it may be of the insulating support, or it may be the or rod, as you can see over here. So these two are the shank which supports the two spheres. Okay, the number 3, that number 3 is the operating gear and motor for changing the gap distance. So here you can see this is the number 3. Okay, this is the number 3 which is used to change the length of gap between the two spheres. 4 number is the high voltage electrode. So here you can see that this is the high voltage line which is connected to the sphere. So ultimately you need to connect. Here you can see one wire is going on. Okay, so this is the high voltage electrode. The P, as you can see, this is the P is known as a sparking point. Why it is known as a sparking point? So here in this case, this is the sparking point or the sparking electrode, as it is connected to the high voltage line. D represents the diameter, as it is spherical in shape, okay, circular in shape. So D represents the diameter. Here you can see over here. S, that represents the spacing. Okay, so this is the spacing between the two electrodes. So normally the spacing in case of the sphere is considered between tip to tip position. Tip means the maximum curvature point. So from here I need to consider the distance. So this is the tip point or the sparking point from where actually the spark is initiated. Okay, so between tip to tip position it will determine the spacing. So here you can see this is the spacing which is between the tip positions of the two spheres. A represents height above P, height of the P it means that the sparking point or the high voltage electrode. Okay, so spacing A. So here you can see this is the spacing A. Okay, this is the spacing A, which is the height of the high voltage electrodes, the sparking point, height of this sparking point with respect to the ground. So in this case this will be your A. Okay, the height of sparking point with respect to the ground. B represents the radius. Okay, B represents this radius, as you can see over here. This is the B, radius of clearance from the external structure. So if you can see in the photograph, okay, there are many of metallic components are present. So when you are performing the test and when you are measuring the high voltage using sphere gap assembly, you have to keep this radius in your mind. Okay, so within this radius there should not be any kind of earth object or the metallic structures are present. You need to remove them out of this circle. So I will show you the table that what should be the radius depending upon the diameters of the two spheres and so on. X represents the high voltage lead should not pass through this plane within a distance of B from P. Okay, so this will be the X. So again inside this radius there should not be any kind of high voltage connections. The high voltage lead should not be passed through this plane within a distance B from P. Otherwise it may cause the unwanted flashover situations between the high voltage electrode, high voltage sphere and the high voltage connected wire. One more thing is this. Okay, if you can see over here, let me represent it with different color of pen. This one, okay, the blue one, the blue box, if you can see over here. So it represents the water filled resistor. The water filled resistor is normally provided to protect the metallic shank against the unwanted oscillations which are created when the high voltage stress is being applied. The value of these water filled resistors depends upon the type of the voltage. If we are supplying AC or DC voltages, then the value of this water filled resistor is higher, okay, in terms of kilo ohms. But if we are supposed to use this facility for the impulse voltage measurements, then the value of these water filled resistors should be quite low. It is in terms of few ohms only. Okay, because if we are increasing the value of resistance, then it will reduces the peak magnitude of generated impulse voltage. So when we are using this assembly for the measurement of impulse voltage values, the water filled resistor should be in terms of few ohms only. But if we are measuring DC or AC voltages, it will be in the form of thousands of ohms value. Okay, so the water filled resistor is acting as a one kind of the damping resistance, which normally damp out the unwanted oscillations which are created when the spark is produced between the two spheres. Okay, so ultimately it provides the protection to the sphere gap assembly. This is the another arrangement. As you can see in a previous photograph, the two spheres are vertically mounted, whereas in this case the two spheres are horizontally mounted. So as I have told you that if the if the voltage which is required to measure is too much large, then vertical sphere gap assembly is more obvious compared to this horizontal one. So the reasons are, if suppose I'm using the horizontal sphere gap assembly for the measurement of, let us say, thousands of kilovolt magnitude. So in that case, as you can see over here, as I'm increasing the voltage value, okay, first and foremost requirement is I need to initiate the voltage at 1000 kV. Okay, so I need to avoid the premature failure or the sparking surrounding the regions or sparking into the air. Okay, when I am increasing the voltage level and reaching to the 1000 kV. So in that case is what I need a larger diameter of the two spheres. So as you can see over here, the diameter of the sphere will be too much large, okay, for measuring the 1000 kV of peak magnitude. So in that case is as I'm increasing the diameter of the sphere, ultimately it also increases the weight of the sphere. So when I am giving the high voltage magnitude, when I am giving the higher voltage magnitude, then electro mechanical forces are generated, and these electromechanical forces will causes the vibration of this, either the metallic shank or the uh, insulating kind of the shank, okay, at which we have provide the support to this high voltage sphere. So because of that vibration, there might be the chance of misplacing the position of tip to tip. Okay, so there might be the misposition of tip to tip. So once it gets misplaced, it may produces the measurement error. Okay, and that we exactly do not want when we are performing the high voltage test. So that is the one drawback. Okay, the another drawback is the diameter. As you can see over here, it needs proper clearance between the high voltage, the sparking point and the ground. So here you can see, the to provide the clearance between the ground and this point, it needs the higher height of the insulating support. So eventually it will add into the cost. Okay, so if we are considering the mechanical kind of the consideration, then the horizontal sphere gap assemblies are not appropriate to use when our requirement is to measure the very high voltage magnitudes. But yes, the horizontal sphere gap assemblies, you can found them in the impulse voltage generators. Okay, so but for measurement purpose, the vertical sphere gap assemblies are more obvious compared to this horizontal one. So spheres are generally made up of either copper, brass or aluminium. Okay, so generally the aluminium type of spheres are more useful. Generally the aluminium type of these spheres are used because of its lower cost compared to the copper and the brass type. The standard diameters varies from 2 centimeter to 200 centimeters. The spacing is so designed and chosen such that the flashover occurs near the sparking point P. The spheres are carefully designed and fabricated so that their surfaces are smooth and curvature in uniform. Okay, because see, if the irregular surfaces are there, then they will promote the corona discharges. Okay, so ultimately it may produces the it will affect the measurement accuracy. So normally the spheres that we are going to use in sphere gap assemblies are carefully designed and fabricated so that we can avoid the irregularities towards the surfaces, just to avoid the inception of the corona discharge activities. Okay, so sometimes it may causes the premature failure events as well. So to keep the field uniform, between the two spheres, the sphere surface must be smooth. The radius of curvature measured with spherometer. Okay, the diameter, the radius of the curvature, that is T point, is measured with the spherometer at various points over an area enclosed by the circle of point 3D around the sparking point. It should not be differ more than plus or minus 2% of its nominal value. Okay, so to measure that sparking point diameter, normally the spherometer is used. The surface of the sphere should be free from dust, grease or any other coating, because it will affect, it will improve the electrical conductivity. Okay, so if the dust particles or the greases are present over the surface, then they always promote the corona discharge activities. The surface should be maintained clean, but it need not to be polished. Okay, because if you are polishing many times, then it will increase the irregularity. If excessive pitting occurs due to repeated spark over, they should be replaced. Okay, ideally you can smooth them by some glass papers or something, but if still the pittings are observed, then you have to replace the spheres, because the pitting will always causes the irregularity towards the surface. So surface gets very rough, and as you know that the roughening surface will promote the corona. The dimensions of the shanks used, the grading ring used if necessary with spheres, the ground clearance, etc. should follow the values indicated in figures, as you can see over here. Okay, and the table as shown. I will show you the table. So here you can see this table. Okay, the clearance for the sphere gap. So here the D is given. Okay, the value of A, maximum and minimum value is given, and value of B, that is minimum value, is given. The high voltage conductor should be arranged such that it does not affect the field configuration. The series resistance connected should be outside the shanks at a distance 2D away from the high voltage sphere or the sparking point P. Okay, as you can see over here, the distance between the external resistor and the sparking point, that is greater than or equal to 2D. So there are the various factors which affects the spark over voltage of sphere gap. Let me see them. First is nearby earth object. If suppose during the testing the earth object lies inside this radius B, when I am giving the voltage, what exactly happens? If this earth electrode is close to this high voltage electrode, then the spark will occur between the earth object and the high voltage electrode. Our intention is to create the spark between the two spheres, but because of the nearby earth object, the spark will divert from its original path and creates a short circuit between the earth object and the high voltage sphere. Okay, so ultimately it affects on the measurement inaccuracy. sometimes it may damage the equipment which may placed close to the sphere gap assembly. Okay, so when we are performing the test, when we are performing the test and measuring the high voltage magnitude with the sphere gap assembly, we should remove the earth objects from this region of B, from this surface, okay, from this radius or the circle. Okay, so once we remove it, then we need to apply the voltage. Otherwise, whatever the voltage that you are measuring is obviously low as compared to your expected value, because the spark has not been created between the two spheres, but actually the spark has been created between the high voltage sphere and the earth object. The atmospheric conditions and humidity. Okay, so atmospheric condition, it means we are considering the delta value. Let me write the values. VBA. VBA represents the breakdown voltage at ambient condition. Okay, ambient condition, it means that we need to consider this delta, and delta represents air density correction factor, and air density correction factor depends upon temperature, pressure and humidity. Okay, on these three factors the delta value depends. So when we are performing the test, we need to continuously monitor the temperature, pressure and the humidity of surrounding atmosphere. Okay, and by multiplying that air density correction factor with the standard value of breakdown voltage, we can able to get the breakdown voltage at ambient condition. But in actual case, we are measuring it with the help of the potential dividers which are associated with the sphere gap assembly. So we all know the effect of the temperature. If we are increasing the temperature, the breakdown voltage decreases because of the presence of the thermal ionizing agents. Okay, there always be the some amount of free electrons remains into the space surrounding the high voltage electrode if the temperature is too much high. Okay, so under that condition, if I am increasing the voltage to a smaller value, it will of course initiate the complete discharge between the two spheres. So we can say that the breakdown has taken place prematurely. So before reaching to the maximum voltage value, the breakdown is initiated because of the higher temperature. Pressure, as you can see over here between the two spheres, the air is acting as a dielectric material, so it obviously follow the Parsons theory. Okay, so if the pressure is more, it needs the higher value of the voltage to initiate the discharge. If the pressure is lower than the atmospheric one, again it needs the higher value of the voltage to create the discharge between the two electrodes. So ultimately the pressure can also affect the spark over voltage of the sphere gap. Humidity. Okay, for the small value of the humidities, for the smaller range, we can observe the reduction in the breakdown voltage with increase in the humidity level. But after a certain point, you can observe the relationship like this. Okay, you can see the characteristic has been drawn between the breakdown voltage and humidity. So as you can see over here, as the humidity level increases, the breakdown voltage requirement also increases. Okay, so there are a lot many of reasons that you can say for getting the improvement in breakdown voltage with respect to the humidity level. The number one is you can also you can justify the statement based on the electronegativity concept, because the humidity is nothing but it indicates the water vapor water particle that is being present into the air. Okay, and water, it means that H2O. Okay, 2H2O, let us consider. Okay, this is the chemical formula of the water. So both the hydrogen and the oxygen are electronegative in nature. So when we are applying the electrostatic field, there always be the electrochemical reactions occurred. Okay, because of that electrochemical reactions, the hydrogen and the oxygen getting separated. Now as both the gases are electronegative in nature, so they have tendency to absorb the electrons to form the negative ions. So these negative ions are heavier in weight as compared to the free electrons, so they are moving with a very lower speed. So ultimately the production of this negative ion affects over the ionization process. So in those cases, if suppose I want to initiate the discharge, what it requires, it requires the high magnitude of force so that the Townsend's ionization breakdown condition will be satisfied. Okay, so once the breakdown condition is satisfied, the spark is initiated. Okay, so as the humidity level increases, the breakdown voltage requirement increases by considering the electronegativity concept due to the involvement of the hydrogen and the oxygen content. The second is you can also justify the statement by considering the partial pressure of the water particle. So in that cases, one can justify the answer based on the Parsons theory. So if we are considering the partial pressure of the water, then of course it affects on the motion of the electrons. So the alpha and gamma value both are going to be reduced. Okay, so as a result, as the gamma value gets reduced, so breakdown condition will not be satisfied until and unless we will improve the kinetic energy of the electron. So the kinetic energy of the electron entirely depends upon the electromotive force. So it needs the higher value of the breakdown voltage to satisfy the condition of the breakdown proposed by the Townsend. Okay, so that is the other reason based on what you can justify your statement that why this breakdown voltage increases with increase in the humidity. The another is justification can be based upon the icing crystals, okay, the solid particles. And as you know that to break the molecular structure of those ice crystals, it needs a tremendous force. Okay, so these are the three possible reasons which you can based on what you can say that the breakdown voltage increases with increase in the humidity, but after a certain condition. With lower humidity, there will obviously the breakdown voltage decreases with increase in the humidity, but after its after somewhat limit, you will observe this effect that breakdown voltage increases with increase in the humidity because of the partial pressure of the water particles, the involvement of hydrogen and oxygen, and the involvement of the ice crystals. Irradiation, it means that if suppose there is an impact of the radiation over the high voltage electrode, then it will assist the photoionization process. So under this situation, the high voltage value or the spark core voltage magnitude reduces as the radiation energy increases. The polarity of the applied voltage, generally the polarity of the applied voltage comes into the picture where the field is strongly non-uniform. In case of the uniform field gap, the breakdown voltage value under positive polarity and negative polarity will remain the same, but the alteration can be observed where the non-uniform field is created. So the uniform field and non-uniform field, it means that uniform field, how we can create them? If the length of separation between the two spheres is lower than the diameter or equal to the diameter, we can have the uniform gap between the two spheres. Let us assume that the diameter of the sphere is 150 millimeter. Okay, suppose I am assuming this diameter, and if I am keeping the length of gap between them is also 150 millimeter. So up to 150 millimeter of LG length of gap, we can have the uniform gap. Uniform gap, it means that the value of ionizing coefficient remains the same at all the point. As an effect, the electric field intensity or the potential gradient at all the points between the two spheres will remains the same. So in that circumstances, even I am changing the polarity, there is no change in the breakdown voltage value. But in case of the non-uniform field gap, it means that the spacing S is greater than the diameter of the two spheres. Okay, under this situation I am getting the non-uniformity concept, and because of the non-uniformity, the distribution of the potential gradient across the gap is non-uniform. So at some places the potential gradient is more, and at some places the potential gradient is lower than the corona inception level. So if we are considering the longer gap length, Then we can also consider the impact of the dust particles and the moistures and everything. So under that circumstances, because of the presence of this impurity level, the electric field intensity becomes higher than the corona inception at the site where the impurity is present. So in that cases first we can observe the development of the corona discharge, and then successively the breakdown has been appeared. Okay, so in case of this non-uniform field gap, if I am changing the polarity, the negative breakdown voltage value which I am getting is more than the positive value. So let me explain that how this happens. So let me first wipe out this. To understand this mechanism, let me consider the point plate electrode. So suppose this is the point electrode and this is the plate electrode. Suppose I am keeping this plate electrode grounded and here I am applying positive polarity. Now between these two, we just imagine that the insulation is present, maybe the gas or the liquid. Now when I am giving the positive polarity, now as you can see over here, the two dissimilar electrodes are there. One is the point electrode and other is the plate electrode. So this setup will give me the strongly non-uniform field. So when I am giving the positive polarity of voltage, the electron is injected. Let me represent electron by this red one. So electron is injected out from the surface of this positively stressed electron. Now what this electron is doing, this electron will gain the kinetic energy and accelerated towards the opposite side. Okay, so during its traveling it will makes a collision with the neutral particle of the gas and produces the electrons and the positive charge. Electron and the positive charge. Okay, so this positive charges, okay, as you can see, normally this process first appear very close to the electrode surface from where the electrons has been injected. So these positive ions are heavier in weight as well, and heavier in weight as compared to the free electrons. Okay, so the electrons are moving faster as compared to the speed of this positive ion. So ideally you can observe that the positive charges are lies very close to the positively stressed electrode. So ideally what we are observing that the diameter of this point electrode is virtually enhanced. Okay, so because of this virtual enhancement, there is a reduction in the length of gap between the two electrodes, and as we know that if the length of gap is less, the breakdown voltage requirement is less. Okay, so whereas if suppose I am giving the negative supply, now let us assume that the point electrode is now subjected to the negative stress. Okay, now I am giving the negative supply. When we are giving the voltage, the electrons are always be injected. Okay, the electrons are there, then the ionization will takes place. So when the ionization takes place, the positive ions are also produced. But in this case, now the positive space charges are acting as a potential barrier. Okay, protecting well, or you can say now they are shielding the electrons which are moving from negatively stressed electrode to the opposite electrode, which is plate electrode. Now as they have created a shield, they will prevent the electrons to move from negative electrode to the plate electrode. So now here you can see that the electrons are stuck because of this positive space charge barrier. So as a result, the ionization into this region is not so much effective. Okay, so ultimately the breakdown condition is not satisfied because the ionization is not effective. So what we need to do to initiate the discharge when the negative polarity is applied, we have to eliminate, or we need to break this screen, positive space charge screen. Okay, so to break this positive space charge shield, it needs the higher kinetic energy of this electron, and the kinetic energy of the electron depends upon the magnitude of the applied voltage. So we need to increase the voltage. As we are increasing the voltage, the kinetic energy or the acceleration or the speed of electron increases, which collides with a higher rate to this positive screen and break it. Once this positive screen gets breaked away, the electrons will now cause a faster ionization and bridge the gap between two electrodes in the form of the spark. Okay, so because of this space charge activity, we can observe the alteration in the spark core voltage when the polarities are going to be changed. Okay, but this effect can only observed where the field is strongly non-uniform. In case of the uniform field gap, the positive breakdown voltage value and negative breakdown voltage value remains the same. But in case of the non-uniform field gap conditions, when we are changing the polarity, we observe that the negative breakdown voltage value becomes higher than the positive breakdown voltage value. So the reason is the space charge behavior. The next one is the impulse voltage measurement. So impulse voltage can be measured either by this potential divider method or by means of peak reading voltmeter. So we have already discussed about this potential divider method, so I am not going to discuss it again, but you can learn it from my previous lectures. So let us discuss the peak reading voltmeter. So as the name giving as a peak, okay, peak, it means that this voltmeter measures the peak magnitude of impulse voltage. Okay, so here you can see basic circuit diagram is provided. So this is the voltage which we are going to apply. Okay, this D is a diode, and this Cm, that is the capacitor which is going to be charged to measure the peak magnitude of the voltage. Okay, and here electrometer is there, so ultimately it measures the voltage. Okay, so you know the nature of the impulse voltage, you know the wave shape of impulse voltage. So here you can see that impulse voltage during its front side, the voltage is being increased to the peak magnitude. Okay, so during this what it does, as the voltage is increasing towards the peak magnitude, this diode D comes in a forward bias condition and acting as a closed switch. So as a result, what happens, it will charge the capacitor. So here you can see that the capacitor is charging to a peak magnitude of voltage. Now as the applied voltage is impulsive in nature, so from its peak magnitude now it will reduce towards zero value. Okay, so when the voltage across this capacitor, when the applied impulse voltage becomes lower than the capacitor voltage, the diode D comes in a reverse bias condition, because when the capacitor voltage becomes higher than the input voltage, the direction of the current will gets reversed. Okay, so during this condition, the diode D comes in a reverse bias condition and acting as an open switch. Okay, so as a result, now if the load is not connected, the capacitor will remains in a charge condition, so the voltage across it will now becomes constant value. Okay, so here you can see this will be the amount of error, because now capacitor is also acting as a filter. So it will remove the ripples which are associated from the output that we are collecting from the diode side. Okay, so this capacitor will remove the unwanted oscillations that is being observed with the output coming from this diode. Okay, so that is why the voltage across the capacitor is somewhat lower than the peak magnitude of applied impulse voltage. Okay, so this is how this capacitor peak reading voltmeter will measures the peak magnitude of impulse voltages. So this figure A represents the basic circuit, figure B represents the equivalent circuit of this circuit A, and this C will represents the waveform of input and meter voltage showing the error delta, which indicates the diode reverse resistance is assumed to be infinite, because under reverse condition it is acting as an open switch. So these all are the methods for the measurement of the high voltages in the high voltage laboratory. In the next lecture, I am going to discuss about the methods through which we can measure the high magnitude of currents. Thank you.